Mechanics paper 4, and this time we are doing November 2021, this third variant. Let's get started. The first question: a metal post is driven vertically into the ground by dropping a heavy object onto it from above. The mass of the object is 120 kg, mass of the post is 40 kg. The object hits the post with a speed of 8 meters per second, remains in contact with it after the impact. Calculate the speed with which the combined post and object moves immediately after the impact. Now the first question, this is a question of momentum. The two objects add up, and sometimes they use the word coalesce. So that is the scene over here. So now initially before collision versus after collision. Before collision the momentum is 120 into 8 and the post is stationary, that is 40 into 0. Afterwards it's 120 plus 40 moving with a velocity of v. So therefore this is 960. This is 160 v. So when you divide, you get the velocity as 6 meters per second. That's a simple question of momentum. Now it says there is a constant force resisting the motion of magnitude 4800 Newton. So in the same question, the scenario is now about F equals to ma. So now what is the equation over here? Let me draw a diagram. So this object, I'm treating it like this. The total mass is 160. So this is 160 G, that's going down. Resistive force is 4800 Newton. It is going down, and we need to find this acceleration. So 160 into 10 minus 4800 is equals to mass into acceleration. So therefore when we do the calculation, this is negative and this comes out to be negative 3200 divided by 160, that is A. So A comes out to be negative 20 meter per second square. Now kinematics. Initial velocity was how much? That was 6. Why? Because that is the answer for the first part. That was the speed with which it was driven in, and it's now coming to rest, and the acceleration is negative 20. So therefore v square is equals to u square plus 2 into negative 20 into s. So therefore when you do the calculation, that is 36 over 40. S comes out to be 0.9 meters. So that was a nice question on momentum, F is equals to ma, and basic kinematics and equation of motion. Question number 2. It says a particle of 8 kg is suspended in equilibrium by two light inextensible strings which makes angle of 60 and 45 degrees. So now it's diagram time. You have to draw the diagram yourself. So let me draw a horizontal, and then the first force, the first tension, that is like this, making an angle of 60 degrees. The second one making an angle like this, and the weight of the particle is acting down. Have a look. This is 8g Newton. Let's label this one as T, the left one, this one as T2. T1 is making an angle of 60 degrees, T2 is making an angle of 45 degrees. It's above the horizontal. So this is the horizontal. When I do the resolution, what happens is that, let's resolve the forces. For the purple one, this is the horizontal component, this is the vertical component. For the blue one, this is the horizontal component, this is the vertical component. So therefore this is T1 cosine 60. This is T1 sine 60. This is T2 sine 45. This is T2 cosine 45. It's in equilibrium, so therefore the first equation is T1 cosine 60 is T2 cosine 45. You can either work in the exact form or decimals. I think it would eventually boil down to decimals, so start with decimals from the beginning. The second equation, T1 sine 60, upward forces equal to downward forces. T1 sine 60 plus T2 sine 45, that is equals to 8g. This is equation number 2. You solve simultaneously. You will find the value of T1 and you will find the value of T2. Find the tensions in the string. First is diagram and second is this equation. So for the diagram, naturally, the diagrams are necessary to form this equation. So I'm just putting it over here, place where it belongs. Now question number 3. Question number 3 is about a ball of mass 1.6 kg. So this is ball of mass 1.6 kg is released from rest at a point 5 meters above the horizontal ground. So let me draw the horizontal ground. So this is the ground. And then it says when the ball hits the ground, it instantaneously loses 8 joules of kinetic energy. So it loses 8 joules of kinetic energy as soon as the ball hits the ground and then starts to move upwards. Use an energy method. Now they have emphasized on this, that use energy conservation of principle of energy. So energy method to find the greatest height the ball reaches after the ground. So that means this question can easily be done using kinematics, but they want us to use the energy method. So now the first thing first, when the particle is at the site, so this ball, what is the kinetic energy? Kinetic energy at the top is 0. Potential energy at the top is mgh 1.6 into 10 into 5. This comes out to be 80 joules. So this is the top. When it's going to hit the bottom like this, so at the bottom, what's happening? That at the bottom we have, let me write it properly. So at the bottom, the potential energy at the bottom is 0. The kinetic energy at the bottom is going to be 80 joules. And the speed with which it hits the ground, let me also calculate it because I have a feeling that I might be needing it later. So half into 1.6 into v square. This is the speed with which it hits the ground. So 1.6 half into 1.6 into v square equals to 80. 2 multiplied by 80 is 160. 160 divided by 1.6. So v square is 160 divided by 1.6. That becomes 1600 divided by 16. So v square is equals to 100. Therefore, v comes out to be 10 meters per second. This is the speed with which it hits the ground. Now let me move ahead and let me draw it further. And now what's happening is that it's gonna rebound. So let me use a purple marker. And now it's rebounding up. But it's not gonna rebound with the same velocity. Why? Because it has lost kinetic energy 8 joules. So kinetic energy at the bottom after hitting is now 72 joules. Keep that in mind. So therefore, this 72 joules is equals to half into 1.6 into w square. That's the new speed with which it's gonna rise up. This was v and this is w. So 2 into 72 is 144 divided by 1.6 is w square. Let me grab my calculator. So therefore this is 144 divided by 1.6. This comes out to be 90. So w square is 90. Therefore w is square root of 90. Let me leave it as it is for right now. Now when it reaches the maximum height, what's happening? So when it's going to reach the maximum height, so at the maximum height, final velocity is 0. In other words, kinetic energy is 0. Therefore, the total energy would be potential. That would be 1.6 into g into the new h. So now first of all, 1.6 into g, that is 10, multiplied by the new h, that should equals to 72. Of course the height would be lesser. So 72 divided by 16, 72 divided by 16, that comes out to be 4.5. So it rises to a height of 4.5. That is the answer for this part. Now why have I calculated the velocities? Because look at the second part. It says find the total time taken from the initial release of the ball until it reaches its greatest height. Now you can use kinematics. So step 1 is from a height of, we don't have the height, we don't need it as such. So that is the first step 1, or let me call it stage 1. That sounds better. So stage 1, initial velocity was 0, final velocity is 10, acceleration is plus 10, so therefore v is u plus at, therefore 10 is 0 plus 10t, therefore t comes out to be 1 second. So it took 1 second for it to reach the bottom. What is stage 2? Stage 2 is going up. Now initial velocity is this velocity, which is root 90. So initial velocity is w, which is root 90, and it reaches a height that is, we already have it. If we want, we have h prime is 4.5 meter. This is meter per second. Acceleration is negative 10 meter per second square, meter per second square, and final velocity is 0. We have more than what we require. So therefore v is equals to u plus at, v is 0, u is root 90, a is negative 10 into t. So what is square root of 90? So let me just flip my calculator, and 90 and square root, that is 9.486. So therefore t comes out to be 0.9486 seconds. Therefore the total time for the journey is 1.9486 seconds. And since we are working in 3 significant figures, so leave the answer as it is. So that was a nice question about energy method and kinematics and gravity and so on. Question number 4. Now the question says, a car of mass 1400 is moving on a straight road against a constant resistive force of 1250 Newton. Now the car moves along the horizontal section of the road at a constant speed of 36 meter per second. Calculate the work done against the resisting force during the first 8 seconds. Now let me underline. This is car of mass 1400, constant force, resistance force, horizontal section, constant speed 36, first 8 seconds, and part 2, calculate the power developed by the engine of the car. And then further on, there is there. Now, if I talk about these two parts, there are 2 ways in which I can work it out. So let me show you both the ways. The first way is basically I would calculate as it is. And the second way is I would first calculate the second part and then I would move to the first part. So now, first thing first, A, part 1, then part 2. And A, part 2, then part 1. Now, as such, it doesn't make a difference what is the order in which you do the question, as long as it makes sense to the examiner, as long you can make it reasonable to the examiner, logical. First part is work done. So work done is force into distance. Resistive force is 1250 into distance is constant velocity multiplied by time. So this is velocity, meter per second into second, that is the distance, and this is the force. Now when you multiply it out, you get 36 with 4 zeros. That is joules. That is the answer for this part. What is part 2? I'm just working it over here. Calculate the power developed by the engine of the car. Now power is work divided by time. So work is 360,000 divided by time, which is 8. So when you divide what do you get? You get 45 with 3 zeros, that is 45,000, and this is watts, and you can also write it in kilowatts, that is 45 kilowatt. You erase the 3 zeros and put a kilo sign. That's one way. Now, if the question was asked, I mean, my personal inclination would be part 2 first, then part 1. It's just a matter of preference and nothing more. So power over velocity minus resistive force is 0 because constant velocity. Mass into acceleration, that's 0. So now power is power. Velocity is 36. Resistive force is 1250. That is equals to 0. So power is 36 into 1250. And when you multiply, you get 45,000 watts. That's the first part. And then you can change it into kilowatts, 45 kilowatts. And then based upon power, you can find the work done. So power is work divided by time. Therefore, work is power into time. So therefore, power is 45,000 multiplied by time of 8 seconds. So therefore, this comes out to be 3, 6, and 4 zeros joules. So there are two approaches to this particular question. Now, the question continues. Now it says, given that the power is suddenly increased. Now, in recent papers, you have seen a lot of suddenly increased or suddenly decreased. Find the instantaneous acceleration of the car. So draw a diagram. The new power, SI diagram is not necessary. It's just that the new power is 45 plus 12. That is 57 kilowatt. That is 57 into 1000 watt. And if you draw a car over here like this, the forward force is 57 into 1000 divided by 36. The resistive force remains the same, that is 1250. What is the mass of the car? The mass of the car is 1400. So therefore 57,000 divided by 3600 divide by 36 minus 1250 is 1400 into acceleration. Hence you will find the value of acceleration. So now this thing is also done. The car now travels at a constant speed of 32 up the section of a road incline at theta with the engine working at 64 kilowatts. A small diagram, a more diagram to show the car, the particle. And then what do you have? You have the forward force, that is 64 into 1000 divided by 32. You have the same resistive force as before because it's unchanged, that's 1250 Newton. And you also have the weight component, so that is theta, and this is 1400 into g into sine of theta, and its constant velocity, therefore acceleration is 0 meter per second square. It's going up. So therefore 64,000 divided by 32 minus 1250 minus 1400 into 10 into sine theta equals to 0. Make sine theta the subject. Hence you will find the value of theta. So that was a straightforward question regarding power and F is equals to ma. So it's about power, it's about work, it's about F is equals to ma, it's about an inclined plane. Next question, that is question number 5, and that is about kinematics. Kinematics with differentiation integration. So this is kinematics and this is differentiation and integration. So kinematics with differentiation and integration. Now let me first go to the examiner report and let's first discuss the first 4 questions. First of all, there are some key messages which are very, very important. Non-exact numerical answers are required correct to 3 significant figures. And that's one thing that you should take care of. Let me add to it. Work in at least 4 significant figures. When resolving forces in equilibrium, when forming an equation of motion, a clear and complete force diagram can be helpful. So when the examiner is saying helpful, for you, draw a diagram. Consider it is a must. So when the examiner is finding it easier, why would you not make the examiner happy? When two separate strings are attached to a particle, two tension should be assumed. So separate strings, separate tension, and so on. Let me move to individual questions. First one, nearly all candidates applied conservation of momentum. That's perfect. Very few omitted, and so on, and some applied conservation of energy. A suitable method was usually attempted, either applying Newton's second law or SUVAT, that means equation of motion. A common error was to omit the weight 160 g when forming the equation. That's a common error. Instead of combined mass, they used either the mass of one or the other. These are the important things. Another one, question 2. Many complete force diagrams were seen. There were also a variety of incorrect or incomplete. The weights was sometimes omitted. How can you omit the weight? Or label the mass as 8 kg. Instead of weight, they use the mass. A normal reaction was occasionally seen even though the particle was suspended. Keep this in mind. Normal reaction or would be there if there is a surface. If there is no surface, how can you have normal reaction? The majority of candidates resolve the forces in equilibrium to find two different tension accurately, even following incomplete diagram. I don't know how that's possible. A few tried to resolve assuming that the tension in each string was the same. And what else was there? More or less this thing. Question number 3. The most direct method in answering this question was to equate the initial potential energy minus 8 joules to find the final potential energy. Many candidates misinterpreted the loss of kinetic energy on hitting the ground, equated 8 joules to the final potential. A correct maximum height could still be obtained from this and this, but this complete method was rarely seen. Those who mistakenly increased the energy by 8 joules found an increased maximum height. This is the funniest. How can you exceed the height from which it was thrown after the loss of kinetic energy, after the loss of 8 joules of kinetic energy? And then the second part was maximum height, velocities. Correctly, the initial velocity was sometimes used, and this thing and this thing. I think what we have done, using that maximum height and the velocity with which it hits the ground, that's more than enough. You will get confused if I read it a little bit further. The work done against resistance was calculated successfully, and the solution for this part was usually fully correct, such and such. Many candidates adjusted the driving force for the increased power, although a few decreased. Who are these people? And while forming the equation, sometimes was missing. Alternative method was just using this. Ignore this for right now. The inclined plane required a component of weight down the plane. That was the extra thing. Constant speed implied no acceleration. And I think that's all about it. So that is the examiner report for the first 4 parts. Now for these 3 parts, let's move ahead. It says there is a particle, it's starting from rest at point O on the line. That means, first of all, the first condition, that is when t is 0, v is 0, s is 0. And then the second condition is when t is 4, v is 8. Now show that s is equals to something for 5 marks, and we have the acceleration equation. Acceleration is k 16 minus t square. That's the first thing. Velocity is integral of this equation, 16 minus t square dt. k as it is, 16t minus t cube over 3 plus c. That is the first part. I'm not multiplying k right now. I'll do that at the end. So now when we have this equation, what should we do? We need to evaluate c. What we do is that when t is 4, v is 8. So v is 8, k as it is. T is 4, that is 16 into 4 minus 4 cube over 3 plus c. And when you simplify it, 64 minus 64 over 3 and such and such. So the first thing is, do we have k? We don't have k. So now what are the equations that we need? Basically, it's forming two simultaneous equations. The first equation is when t is 0, v is 0. So therefore, I have plugged in the second one. Let me do it in order. So let me move this thing to the side for right now. Let me move this thing up. When t is 0, v is 0. Therefore 0, k multiplied with 0 minus 0 plus c. So therefore c comes out to be 0. That resolves the thing. So therefore this times c is 0, and let me erase it. So now the equation is, now v equals to k bracket 16t minus t cube over 3 plus 0. Now plug in the second condition. When t is 4, v is 8. When t is 4, v is 8. So therefore 8 is equals to k multiplied with 16 into 4 minus 4 cube over 3. And this, after the working, k comes out to be 3 over 16. Therefore your velocity equation is 3 over 16 and 16t minus t cube over 3. 16t minus t cube over 3. Now the displacement equation. Integrate this thing. 3 over 16. 16t minus t cube over 3 dt. That is 3 over 16. 16t square over 2 minus 1/3, and t cube becomes t power 4 over 4 plus a constant of integration. Let me call it c. Let me write this thing as t. Now when t is 0, s is 0. Therefore d comes out to be 0. Therefore the equation s is 3 over 16, 8t square minus t power 4 over 12. Let me double check what's the answer. 1 over 64, 96 minus t square. So they have taken something common out. So let me go to that extent. S is 3 over 16 and take LCM. So 12 8s are 96. That is 96 t square minus t4 divided by 12. Now 16 into 12, I can simplify it. So therefore, let me first double check. This is 8 and 3 4s are 12, and 16 into 12, 3 1s are 3 4s are, and that is 64. So no need to multiply. So that is 3 over 64. And take t square common out, and that is 96 minus t square. So now this is in that particular format. That is 96 minus t square. Now it says find the speed of p at the instant it returns to O. So when a particle returns to O, it means the displacement is 0. So therefore that is why they have factorized this. So S is equals to 3 over 64, and this is t square, 96 minus t square, and make it equal to 0. So the 3 over 64 disappears, t square disappears, t comes out to be 0. 96 minus t square is 0, t square is 96, therefore t is square root of 96. So if you want to factorize this further, or just use a quadratic formula, I think that's more than enough. Just use the decimal value if you want to, or leave it as it is. We are interested in finding the velocity, I think, the speed. That means if it's negative, ignore the negative side. So therefore this is 3 over 16, 16t minus t cube over 3. 3 over 16, 16t minus t cube over 3. So this is 3 over 16, and this is 16 multiplied with root 96 minus root 96, the whole thing cube over 3. So it's sensible to use a calculator, and after you do the calculation, this comes out to be 29.4 meter per second, correct to 3 significant figures. That is the velocity. Find the maximum displacement of the particle. For maximum displacement, derivative of displacement should equal to 0. So this is a P1 turning point scenario. Now, velocity is basically ds by dt, and velocity is 3 over 16, 16t minus, also take t common out, t 16 minus t square. Got the idea? And this is t square over 3. So now v equals to 0, therefore t equals to 0, therefore 16 minus t square over 3 equals to 0, therefore t comes out to be square root, t square comes out to be 48, therefore t comes out to be square root of 48 meter per second. And they are asking for the maximum displacement, so when t is root 48, the value of displacement, this equation is 3 over 64. My bad, this is not 3 because the 3 disappears. Let me use a small eraser. This is 1. And this S is this thing, that's the final answer. S is this much. This is also 1 because the 3 was cancelling out. And velocity is this. So S is equals to 1 over 64. And it's t square, 96 minus t square. So this is t square and 96 minus t square. So therefore this is 48, this is 64, this is 96 minus 48, and you will get a clear answer that comes out to be 36 meters. Now this was question number 5, and this was about kinematics. Now let's see if there are 2 questions left or 1 question left. So this time it's only 1 left, and I'm feeling delighted about it. So this is a question about Newton's laws of motion. So this is about connected particle, and let's see how to proceed. Now, very rarely have they given us a question in which there is a table and 2 freely hanging masses are over there. Now let's read the question. The diagram shows a particle of mass 5 kg on a rough horizontal table. So that's the first thing that needs underlining. It's a rough horizontal table. 2 light inextensible strings, smooth pulley, masses are 4 and 6. Hangs freely. The particle of mass 6 kg is 0.5 meter above the ground. The system is in limiting equilibrium. Show that the coefficient of friction is 0.4. That is for 2 marks. So the first part is that what you do is that it's in equilibrium. That means let me do some labeling. So this is like this, and tension is like this way. Let me label it. There is a tension here, and the same tension is this way. Then there is a tension this way, there is a tension this way, and let me label this thing as this. Now let me start labeling. This is 6G. So first thing first, this is 6G, and on the right I'm labeling this as T1. This is T1, this is T2, this is T2, this is 5G, and there is an R over here, and the 4G is like this. It's in equilibrium. First of all, T1 is equals to 6G. T1 equals to 6G. Second thing, T2 is equals to 4G. T2 equals to 4G. Now I don't have to write the full-fledged equation that 6G minus tension is 6A. It's just obvious. Now over here, it has a tendency of moving to the right. and that is the second parts will also agree to this, that find the time that elapses the 8 kg particle hits the ground. So that is for the next part. The 6 kg is now replaced by a mass of 8 kg. So it has a tendency, since 6 kg is greater than 4 kg. What is missing piece of the puzzle? The missing piece of the puzzle is there should be a frictional force acting to the lift, F max. So now R equals to 5g. F max is equals to mu R, that is mu into 5 into 10, that is 50 mu. Now what is the equation for this part? T1 is to the right, T1 is to the right, T2 is to the left, F max is to the left. So T1 is 6g, T2 is 4g, F max is 50 mu. This is 60 minus 40 divided by 50, that is equals to mu 20 over 50. So mu comes out to be 2 over 5 or 0.4. That is the answer for this particular part. That's for 2 marks, but it was not straightforward as such. A lot of work was involved. That's the first thing. Now, what's the second thing? The second thing is the 6 kg is now replaced by a particle of mass 8 kg and the system is released from rest. So now the weight is 8 kg, released from rest. Find the acceleration of the 4 kg particle and the tensions in the string. That means now you have to apply F is equals to ma. Now what would be the equation? First of all, we have 8g minus tension is 8a, that's the first one, and this is tension 1. Tension 1 minus tension 2 minus the F max, which was already given as 50 mu. So now F max is 50 into 0.4, that is 20 Newton. So F max is 20 Newton. Minus 20 Newton, you can write in brackets, this is F max, is equals to mass, which is 5 into A. And now the scenario is like this. This is going down with a new weight. This is acceleration. This is acceleration. This is acceleration. And the last one is T2 minus 4g equals to 4a. So this is the particle. This is for the 8 kg. Let me label it. This is for the 8 kg. This is for the 5 kg. This is for the 4 kg. And now the overall equation is for the system. So now the system equation is coming up. The tension would cancel. 8g minus 20 minus 4g, that is 8 plus 5 plus 4, 12 plus 5 is 17. 80 minus 20 minus 60. 80 minus 20 minus 40. 80 minus 60 is 20. So 20 is equals to 17a. Therefore, the value of A in fraction is 20 over 17 meter per second square. That's the first thing. Now, what else is it asking? In the tension in the string. Now, just use any one of the two equations. If I use the first equation, 8g minus tension 1 is 8 into 20 over 17. Use a calculator, you'll find the value of tension 1. Secondly, last equation, T2 minus 4g is 4 into 20 over 17. Therefore, T2 comes out to be some other value. So you got T1, you got T2. Let me use a calculator. So T1 comes out to be 70.6 Newton. T2 comes out to be 44.7 Newton. So these are the two answers that you get. This is T1, this is T2, this is acceleration. So far so good. So 2 marks and 5 marks. Now some extra space is given. In the subsequent motion, the 8 kg particle hits the ground and does not rebound. And let me add one more term. The string becomes slack. That means there is no more tension in the string. find the time that elapses uh, between after the 8 kg hits the ground and the other two particles comes to instantaneous rest. You may assume that this occurs before either particle hits the pulley. Now, why do you think they have given this thing? That is the distance of how much? That is 0.5 meter. So let me add one more thing. Initial velocity is 0, acceleration is 20 over 17, distance is 0.5 meter. I'll find the velocity with which the particle hits the ground. So v square is u square plus 2 into 20 over 17 into s, which is half. So v square is 20 over 17, or v is 20 over 17 square root. Leave the answer as it is for right now. Now it says the particle becomes slack and so on. So for that second particle, that is the 5 kg mass. So let me write it again. The 5 kg particle, and then there is this 4 kg particle, and then we would add it up for the system. So now, first of all, let me write system over here. It's the same equation as before, this one. It's the same equation as before, except T1 is gone. Except T1 is gone. Everything else is there, intact. So 0 minus T2, 0 minus T2 minus F max, which is 20, is equals to mass into acceleration. And similarly, T2 minus 4g is equals to mass into acceleration. When you add it up, minus 20 minus 4g is equals to 9a. So therefore, minus 60 divided by 9, acceleration is negative 60 over 9 meter per second square. Of course, that's slowing down. Now, what are they asking? They are asking, find the time that elapses after the particle hits the ground and the other two particles comes to instantaneous rest. So now it's just kinematics. So now the previous part, final velocity, is now the initial velocity, which is this one, 20 over 17. That's the square of it, 20 over 17. And final velocity is 0. So we have what? We have acceleration, we have initial velocity, we have final velocity, and they are asking us the time. So therefore, v is equals to u plus 80, and v is 0, u is 20 over 17 square root, a is negative 60 over 9 multiplied by t. Now you can use a calculator and then you get the answer as 0.163 seconds. So that was a nice, well-rounded question, checking everything. So you cannot assume that the examiner is going to ask this or that. You have to be super fluent in every single topic. Now let me go to the mark scheme. Let's go first to question number 6. It says, the question was generally well answered, but B and C proved to be particularly challenging for many candidates. First part was easy, let's ignore that. The solution was expected to involve 3 simultaneous equations for the 3 particles. We made that. The situation was frequently oversimplified by the assumption that the tensions were equal. I don't know why people assume that. 2 different strengths, 2 different tension. And I think that is what the mistake that people made. Part C. This solution depended on recognizing that the acceleration after the 8 kg particle hits the ground needs to be calculated either from a system of equation for the 2 particles in motion or from solving simultaneous equation of motion. Many candidates assume either the acceleration was minus g or the same as found in part 1. Those who recalculated the acceleration sometimes used a faulty equation instead of such and such. Some calculated different accelerations for each of the 2 particles despite the connection. As long as it's a connected particle, how can they have different acceleration? And so on. So this is all the mistakes that people did. And question number 5 was about kinematics. The question was well answered by a majority of candidates who understood that integration was needed. Fully correct solutions were often seen. Only a few candidates attempted to use constant acceleration formula. You cannot use it. You can't use SUVAT, the equations of motion formula for questions related with differentiation, integration. Why? Because the acceleration is variable. It's dependent on time. So how can you use it? Now, what else? Most integrated and then calculated case successfully following the substitution of t is equals to 4, v is equals to 8. We did that. Those who included a constant of integration without recognizing that c is equals to 0 were unable to evaluate k. That means there were two, I'll take you back to the question in a short while. There were two pieces of data in that question. Others integrated twice, inappropriately used the given answer to find the value of k rather than finding k in order to show the answer. Now this is important. Inappropriately use the given answer to find the value of k rather than finding k in order to show the answer given. You cannot use a value which the examiner is asking you to show. Candidates were expected to solve st is equals to 0 in order to find the time taken and hence the speed to return to O. Some assume that a is equals to 0. Most common error was to find the velocity correctly as this, but omit to state the speed 29.4 as was required. Let us double check whether I've done it correctly or not. Maximum displacement required the solution of derivative of displacement equals to 0 and so on. So now in this question, we evaluated this thing, that is 29.4. So this was coming out to be negative. Since I did not use a calculator, this was negative, but speed was required. So therefore, what should we do? We would say speed is 29.4 meter per second. So speed will always be positive because that is the magnitude. So now that completes this paper and this whole series for the preparation of May-June 2022 exam. And good luck with your exam, and just go through the papers, just focus on 2021 papers. This was November 2021 and this is variant 43, and do watch the November 2021 variant 42 as well as the March 22 paper. Take care.